Imagine for a second that you're a highly trained radiologist.
Okay.
You've studied medicine for well over a decade, right? You know the human body inside and out.
Right.
So you're looking at a chest x-ray on your monitor, and based on all your years of grueling experience, you see a perfectly healthy lung. But suddenly,
Let me guess. The machine disagrees.
exactly, the new multi-million-dollar AI system your hospital just installed flashes this bright red warning on the screen. It beeps, and it flags the scan as high risk for malignancy. Terminal.
Yeah, I mean, it's the ultimate modern standoff, isn't it? The human expert versus the black box.
It really is. Like, who do you trust in that moment? Do you trust your own eyes, or do you trust this algorithm that can theoretically process, 10 million similar scans in the blink of an eye?
It's a terrifying position to be in.
Right. And right now, in almost every boardroom across the globe, there is this absolute obsession with AI acting as a kind of magic wand.
Oh, absolutely.
If you're a manager, a creative, or honestly just someone trying to navigate the modern workplace, you've probably been fed this exact corporate fantasy. The pitch is always just buy the software, plug it in, watch the profits soar, and watch human error completely disappear.
Which is incredibly seductive, right? The idea that an algorithm is just this frictionless instant upgrade to your entire operation. But the reality on the ground is, well, it's far messier.
So much messier. And here is the startling reality that nobody in those executive boardrooms really wants to admit out loud. Simply dropping AI into a workflow often makes human decision-making measurably worse.
It actively degrades performance, which completely contradicts every sales pitch you've ever heard.
Completely. And that is exactly what we are exploring in this deep dive. Today, we're looking at a really fascinating framework paper by Dr. Jonathan H. Westover, and it's called Calibrating Human AI Teams.
It's a brilliant piece of research.
It really is. So our mission today is to shortcut your learning curve on how to actually make these collaborations work in the real world. We're going to explore the bizarre psychological traps we all fall into when we work with machines, and how the smartest organizations are fixing those traps to achieve what they call collective intelligence.
Love that term.
Yeah, that's great. Okay, let's unpack this. Why is plugging in this brilliant software actually backfiring? Where does this whole implementation gap even start?
Well, it starts entirely with human psychology. You see, organizations are spending absolute fortunes on these incredibly sophisticated platforms, but they're completely ignoring the cognitive reality of the human beings who actually have to use them.
Right.
Let me give you the one statistic from the research that I think just perfectly captures this failure. So 85% of large organizations have deployed AI systems for knowledge-intensive decisions.
Okay, so basically everybody.
Basically everybody. But only 31% see actual improvements. And nearly a quarter of them, 23% to be exact, document outcomes that are actually worse than before they had the AI.
Wait, 23% are getting worse results?
Yeah,
They spent millions of dollars to actively damage their own efficiency?
precisely. And what's fascinating here is why this happens. The research highlights a few specific psychological traps. The first one is called algorithm aversion.
Which is essentially just like holding a grudge against a computer, right?
Pretty much. It's what happens when a human decision maker sees an AI make a single isolated mistake.
Ah.
Maybe the algorithm misinterprets a weird piece of data just one time. The human immediately says, aha, see, this machine is stupid. I knew it.
Right, they feel validated in their skepticism.
Exactly. And from that point forward, they systematically reject the AI's recommendations. Even when the AI is perfectly accurate, they write the whole system off because of one error that didn't align with their human common sense.
I feel like we see this in everyday life all the time. I like to call it the GPS dilemma.
Oh, I like that.
Yeah, so algorithm aversion is when you're driving home and the GPS tells you to take the highway, but you convince yourself, a local shortcut better than the satellite that is, currently analyzing millions of live data points.
Right, you think you're outsmarting the traffic.
Exactly. You ignore the machine, you take your shortcut, and you end up sitting in an hour of bumper-to-bumper traffic.
That is exactly it. And the flip side of that, the second trap, is what researchers call automation bias.
Right, which, sticking with the GPS dilemma, is when you drive your car straight into a lake because the screen confidently told you to turn right.
Exactly.
You just completely ignore your own eyes, the physical road, and the giant body of water in front of you just because the machine sounded so sure of itself.
Yes, and what's fascinating here is the underlying mechanism at play in both of those extremes. Both driving into the lake and stubbornly sitting in traffic stem from a failure to achieve what we call complementary intelligence.
Complementary intelligence. Okay, break that down.
Well, think about it. The goal of bringing AI into a workplace is not for the AI to replace human thinking, right? Nor is it for the human to just ignore the AI. The goal is to create a new system entirely.
A partnership.
Exactly. You want the AI's incredible computational advantages, like recognizing a pattern across a billion data points, to seamlessly intersect with human cognitive strengths.
Because humans are still, infinitely better at contextual understanding, reading a room, and applying actual ethical reasoning.
Exactly. When those two types of intelligence don't complement each other, you don't just get a neutral result, you get active destruction. Which brings us to a third trap, which is capability confusion.
And that's when nobody knows who's supposed to do what.
Basically, it's when an organization has no idea which parts of a decision should be handled by the human and which parts by the machine. They just throw them both in a room and hope they figure it out.
And we really need to talk about the sheer scale of the damage that causes, because the hidden costs of this bad collaboration are just massive. Let's go back to that radiologist scenario from the beginning.
Yeah, that's a perfect example.
When you look at the organizational costs there, the numbers are genuinely alarming. The data shows that when radiologists fall into these psychological traps, like when they systematically over-rely on the AI for easy, low-risk cases, but then stubbornly disregard the AI on the complex cases, their net diagnostic accuracy actually drops.
Which is terrifying when you consider we're talking about medical diagnoses.
It really is. It drops by up to 14% compared to when they collaborate optimally. And this spreads across entirely different industries, too. Take financial loan officers.
Oh, the finance data is wild.
Right. If a loan officer has wildly inconsistent trust in their algorithmic risk assessments, sometimes blindly trusting it, sometimes ignoring it, they end up increasing their portfolio default rates by 11 to 17%.
And my favorite example of this chaos is in supply chain management.
Oh, yeah, the inventory hoarding.
Yes. Picture a supply chain manager heading into the holiday season. The forecasting AI looks at the data and says, actually, you need to order 20% less stock this year. But the human manager's gut says, are you crazy? It's the holidays. We'll run out.
They panic.
They panic. They don't trust the machine. So they completely override it and end up hoarding inventory. The research shows this kind of poor collaboration creates between 23 and 35% in excess safety stock. They are literally filling warehouses with junk because of a psychological trust issue.
Okay, wait, I have to push back on this a little bit, specifically regarding the doctors and the highly trained professionals. It's kind of breaking my brain.
Sure, go for it.
You're telling me that giving a specialized radiologist advanced AI assistance actually makes them worse at their job? I understand the panic in a supply chain, but a doctor? How does the presence of more data make a doctor worse?
Because poorly implemented AI fundamentally changes the nature of the professional's job, and not in a good way. It strips them of their autonomy and introduces severe role ambiguity.
Role ambiguity, meaning they don't know what they're supposed to be doing.
Right. Let's look at the mechanism here. If an algorithm just flashes cancer on a screen, without explaining its reasoning, what is the doctor's actual role in that moment?
They're just a rubber stamp at that point.
Exactly. They are reduced to what the literature calls an algorithmic validator. If you spend 10 years in medical school, and suddenly your job is just clicking approve or deny on a computer's guess, you don't know what your unique value is anymore. Your professional identity takes a massive hit.
So you just mentally check out.
You mentally check out, you experience severe burnout, and here's the most dangerous part. Your skills actually atrophy.
Wow.
Yeah. If the machine does the heavy lifting every day, your cognitive muscles waste away. The research highlights an incredibly pertinent example of this from commercial aviation.
Oh, with the autopilots.
Right. Pilots who depend excessively on autopilot systems demonstrate measurably degraded manual flying skills.
Because they just aren't getting the reps in.
Exactly. And when a sudden storm hits, or the autopilot system fails, they lack the sharpened split-second instincts needed to recover the plane because the machine has been flying in clear skies for months.
That makes total sense.
And that exact same skill degradation happens to doctors, financial analysts, and customer service reps when AI takes over the core process without preserving the active human element.
Which brings us to the actual solutions. If the financial and human costs of this bad collaboration are this high, if we are misdiagnosing patients and crashing planes, How are the smartest organizations fixing the trust issue?
Well, they're being incredibly intentional about it.
How do we calibrate this trust? Because it sounds like you can't just send out a company-wide email saying, hey, everyone, please trust the new software.
No, you absolutely cannot mandate trust. Trust has to be earned through transparency.
Okay.
The first major structural fix that emerges from the research is transparent algorithmic communication. In plain English, the AI needs to show its math. Think about it from the user's perspective. If an AI just spits out a final recommendation, a human has zero framework for evaluating if it's right or wrong. But if the AI provides contextual explanations for why it reached that conclusion, human trust can be properly calibrated.
The Mayo Clinic case study in the source material is a brilliant illustration of this.
It really is.
They didn't just give their radiologists a black box AI that spat out a binary cancer or no cancer result. That's useless. Instead, the AI provided heat maps.
Right, it showed its work.
Exactly. It physically highlighted the specific regions of the X-ray image that influenced its prediction. It also provided a confidence score that was contextualized by the patient's specific characteristics, like their age or, their smoking history.
And that changes the entire cognitive dynamic. The doctor isn't just looking at an answer, they are evaluating a rationale. They see the red glow on the heat map, they cross-reference it with the patient's history, and suddenly they aren't blindly agreeing. They are collaborating.
It's a dialogue.
Exactly. And what was the outcome of showing the math?
A 17% higher diagnostic accuracy compared to their pre-AI baseline.
17% is huge in medicine.
Massive. And we saw the exact same mechanism work in banking. JP Morgan Chase started forcing their AI to explain itself to loan officers.
Oh, right.
The system would flag unusual applicant characteristics and actually reference the specific financial indicators it used. When the human could actually see the logic, they knew when to trust it and when to overwrite it. And that transparency led to an 11% drop in portfolio default rates.
But here's the catch. Transparency alone isn't a silver bullet.
Yeah.
You can show a human the math all day, but if they don't know how to read it, it doesn't matter.
Right, you need the skills to interpret it.
Exactly. So the second part of the solution is structured trust calibration training. You can't just hand someone a login to the system. You have to actively train their brain to interact with the algorithm.
The Cleveland Clinic ER triage program is the perfect example of how to do this right.
Oh, I love this example.
Yeah, they didn't just have their emergency doctors click through some boring HR software tutorial. They put them through a rigorous 6-week simulation program.
Wow.
Imagine sitting in a simulator looking at a patient chart. The doctors practiced analyzing cases where the AI was completely right and the human was wrong.
Okay.
But, crucially, they also practice on cases where the human was right, but the AI missed critical, invisible, contextual clues, like a patient who was sweating profusely but had normal vitals.
So they were actively hunting for the blind spots.
Yes.
They were learning exactly where the machine excelled and exactly where it fell apart. By practicing the overrides in a safe environment, they achieved a 19% faster identification of high-severity cases in the real emergency room.
Here's where it gets really interesting for me. I think about this whole dynamic, the transparency, the training like dealing with a brand new coworker.
Okay, tell me more.
Think about your own workplace. If a new coworker walks up to your desk on their first day, drops a massive final report in your lap, and just says, here's the answer, go present it, you are inherently not going to trust it.
No way! You don't know them. You don't know how they think.
Exactly. You'd probably double-check every single number, which entirely defeats the point of having help.
Right.
But if that same new coworker pulls up a chair and says, hey, here's the answer I got. Let me walk you through how I arrived at these numbers, the historical data I pulled from, and hey, here's one variable I'm actually a little unsure about.
It's completely different.
Suddenly, everything changes. You learn their strengths. You learn they're great at spreadsheets, but terrible at reading market sentiment. You learn exactly when to trust their judgment.
That is a phenomenal analogy because it highlights a critical point from the research. Blind trust in AI is just as dangerous as zero trust.
Right.
Organizations shouldn't be aiming for maximum trust. The goal is calibrated trust, knowing the exact boundaries of your digital partner's competence.
Okay, so let's say we have that calibrated trust. We know the new coworker's strengths and weaknesses. How do we actually divide up the daily workload? Because if the human is still just verifying every single thing the AI does, we lose all the speed and efficiency we paid millions of dollars for.
That leads us to the next structural fix, which is capability-based task allocation.
Right.
Which is really just an academic way of saying, You assign tasks based on comparative advantage. You give the AI the data-heavy, routine, mind-numbing pattern recognition, and you actively reserve the ambiguous, novel, and ethical decisions for the human beings.
Amazon's supply chain is the gold standard for this, right?
Absolutely.
Amazon uses AI to forecast demand for established, stable products. Think about something like paper towels. The algorithm can analyze historical sales, seasonal dips, and promotional effects infinitely better and faster than a human ever could.
Right. The data is highly predictable.
But what about a brand new product launch? Or what about a sudden global crisis, like a pandemic?
In those situations, historical data is completely useless. I mean, an AI looking at 2019 data during the spring of 2020 would tell you everything is perfectly normal.
Right.
It takes a human looking out the window to realize the world just shut down.
Exactly. So for those novel, unprecedented situations, the human analysts completely take the wheel. By dividing the labor that way AI handles the mundane, humans handle the weird. They achieved a massive 27% reduction in wasted inventory while actually improving product availability.
But, and this is a big but,
Right.
to make that division of labor actually function on a random Tuesday afternoon, organizations had to establish something even more foundational than software:
What's that?
psychological safety.
Yeah.
The humans in the building must feel completely safe to overrule the machine.
Okay, I have to challenge this because this sounds great in a textbook. It's really easy for a researcher to say, just question the AI. But think about the real world. Is it actually realistic to expect a 25-year-old junior employee or even a mid-level manager to override a $10 million corporate algorithm without fearing for their job?
It's a very fair question.
I mean, if that junior employee overrides the AI and they happen to be wrong, won't management just instantly say, why didn't you listen to the expensive software? You're fired.
This raises an important point, and it strikes at the heart of why traditional management metrics completely fail in an AI-augmented workplace.
Okay.
If you evaluate the human and the AI in isolation, you create an absolute culture of fear. If the human employee is judged solely on outcomes, and they know they'll be punished for disagreeing with the computer, they will just blindly follow the AI.
Yeah, they'll just hit approve to avoid getting blamed.
Exactly. To fix this, leadership has to completely change how they measure success. You have to measure the collective performance of the team, the human and the AI together, and actively remove the individual blame game.
So how does a company actually do that without descending into total chaos?
Look at how Intermountain Healthcare handled it. They built psychological safety directly into their weekly routines by creating no-fault learning forums.
No-fault learning forums.
Yeah. Every single month, their doctors get together in a room specifically to discuss cases where they questioned or actively overrode the AI's recommendations. And here is the key. The hospital leadership explicitly praises that thoughtful skepticism.
Oh, wow.
Even if the doctor's override ended up being wrong, they're celebrated for double-checking the machine.
Oh.
The leadership frames it as a vital demonstration of clinical expertise, not as stubborn resistance to new technology.
So they actively celebrate the friction.
They celebrate the friction. And the internal surveys showed an 87% comfort level among their physicians when it came to challenging the algorithm.
That's huge.
It is. Compare that to only 42% at other hospitals that didn't have those safety protocols. By removing the fear of being fired, they allowed human judgment to actually act as a safety net, rather than just a passive rubber stamp.
So we forced the AI to show its math, we've divided the tasks based on who is actually better at them, and we've removed the fear of speaking up. But the research really emphasizes that this is not just a one-and-done software installation.
No, not at all.
How do organizations ensure this human-AI collaboration actually gets better year after year rather than just stagnating?
They have to build what are called dynamic learning systems. The collaboration must be a two-way street. It is not just about the human learning how to use the AI. The AI fundamentally has to learn from the human's intuition.
The Capital One credit evaluation system blew my mind on this front.
Oh, it's brilliant.
Let's say a human loan officer is looking at an application. The algorithm says deny, but the human officer notices some nuanced contextual factor, maybe a localized economic event that the AI doesn't understand, so the human overrides the system and approves the loan. That override isn't just ignored, it is meticulously tracked. If the human turned out to be right, and the loan is paid back, that data is fed directly back to the engineering team. They use the human's intuition to train the AI to recognize that nuanced pattern in the future.
It literally makes the machine smarter. And it works in reverse, too. Sometimes the AI discovers a bizarre, Non-obvious correlation between applicant characteristics and default risks something a human brain would never naturally spot.
Because it can look at millions of points at once.
Exactly. When the AI finds that, the insight isn't just kept in a server room. It is used in quarterly training to expand the human loan officer's own evaluation frameworks.
It's a continuous loop of improvement, and that bidirectional learning bumped their combined human-AI prediction accuracy up from 76% to 88%.
And to sustain that loop over the long term, organizations have to implement distributed governance. You cannot have AI governed solely by a centralized, disconnected IT department.
Right.
The frontline workers, the people actually collaborating with the AI in the trenches every single day, need a structural say in its design and evolution.
Which makes perfect sense. If we go back to our new coworker analogy, you wouldn't let the HR department dictate exactly how you and your coworker manage your daily spreadsheet.
No, that would be a nightmare.
You and the coworker figure out your own rhythm. The source material talks about how Siemens Healthineers actually set up regional advisory boards made up of the actual frontline radiologists using their diagnostic AI.
Yeah, giving them a real voice.
Exactly. Those doctors review the performance, they flag the annoying user interface challenges, and they tell the data science teams what to prioritize next. It completely bypasses the usual corporate bottleneck.
And crucially, human judgment must always remain in the loop to act as the ultimate ethical backstop. This is something we can't ignore. An algorithm only optimizes for the data it is fed, but organizations operate in real, messy human societies with ethical realities. When you blindly feed historical data into a machine, it will confidently replicate the biases of the past. The research highlights Microsoft's approach here. They run rigorous audits to monitor for bias across all demographic groups.
Right. The research specifically noted their AI-assisted hiring tools. The continuous monitoring revealed that the algorithm was actually prioritizing historical hiring patterns that correlated with gender bias.
Because that's what was in the old data.
Exactly. The AI didn't know it was being biased. It was just doing the math on past data. So interdisciplinary teams of humans had to step in, refine the algorithm, and fundamentally change the human review protocols to fix it. The humans had to step in and say, no, this is how we want to operate ethically.
If we connect this to the bigger picture, it changes how we view the technology itself. AI isn't just a static piece of software you buy and plug into a wall. It is a dynamic organizational capability.
I love that.
The companies that dominate knowledge-intensive industries in the next 10 years will not be the ones who just buy the most expensive algorithms. They will be the ones who successfully weave AI into the cognitive, behavioral, and ethical fabric of their human workforce.
So what does this all mean? If I had to summarize everything we've unpacked today, it's that true competitive advantage doesn't come from having the smartest machine. It comes from building the smartest human-machine relationship.
Beautifully said.
It's truly like a dance partnership. It is absolutely not a master-servant dynamic where one just blindly dictates commands to the other. It's two partners on a dance floor whose steps get tighter, more intuitive, and more synchronized the longer they work together.
Right.
But that only happens if they are communicating transparently, if they trust each other appropriately, and if they deeply respect each other's boundaries.
And, crucially, it only happens if the environment allows them to occasionally step on each other's toes without the music stopping entirely. That psychological safety, the freedom to fail, question, and learn, is the engine that powers the whole system.
Which leaves me with a really profound thought to chew on, something that builds directly on what we discussed about skill atrophy and dividing up the capabilities.
Oh, I'm intrigued.
We talked about how the ultimate goal is to give all the routine, straightforward, repetitive practice tasks to the AI, right? So we can free up the human mind to handle the complex, the novel, and the highly ambiguous situations.
Yes, that is the holy grail of capability allocation.
But if we actually achieve that, well, if the machine takes all the routine practice rounds, how do the entry-level humans of tomorrow ever get the basic practice they need to become the experts of the future?
Oh.
If you never learn to fly the plane manually in clear, boring skies, how on earth do you handle the storm when the autopilot fails? If the algorithm is doing all the foundational reps, where does our next generation of human intuition even come from?
That is going to be the defining challenge for the next era of human work. We have to figure out how to train the human while utilizing the machine.
We really do. The boardroom might be desperately looking for a magic wand to wave over their profit margins, but what they really need to be building is a dance floor. And they need to teach both partners how to move. Thank you for joining us on this deep dive. Think about your own workflows, keep questioning the machines, keep exploring, and we'll catch you next time.